For problem number 5, we have a street light and a person, and we're interested in the rate at which the person's shadow is lengthening. So hopefully the picture has brought you to a triangle, specifically some similar triangles. So I'm actually going to take that picture and just pull it off so we can just see the triangles. Alright, what data do we know? We know that the person is 6 feet tall, so we can put a 6 right here. We know that the street light is 15 feet tall, so we can put a 15 right there. We're interested in the rate at which the person's shadow is lengthening, right? But we don't know the length of the shadow at the moment, so that's our unknown. So we don't know what x is. We also know that we're trying to find dx dt. We can create a proportion because we have similar triangles due to the right angles and the common angle on the right side. So by angle, we have similar triangles. Similar triangles produce proportional sides. So if we look at the base of the small triangle, it's x, and the height of the small triangle is 6. So we have x over 6. Now we need the base of the entire large triangle. Well, x gets us this far, but we have some more right here that we haven't accounted for yet. That we don't know, so let's call it y. So the base of the large triangle is actually going to be x plus y. The height of the large triangle we know is 15. That gives us a proportion. And in addition to that, we have one more piece of information we haven't talked about yet, and that is that the person is walking away from the base of the street light at a rate of 4 feet per second. So what's changing is this distance right here. That's dy dt. So we are told that dy dt is equal to 4. All right. So what we're going to have to do here is we're going to have to derive this equation, and then we can work in dy dt to find dx dt. So how you want to go about this is totally up to you. If you're not a fan of fractions, we know from the fact that since we have a proportion, we can cross multiply. So we actually have 6x plus 6y is equal to 15x. And then we can move 6x over to the right side. So we actually have the equation 6y is equal to 9x. Now if we derive this equation with respect to time, all right, so we're going to do a ddt of both sides. Then we're looking at 6 dy dt is equal to 9 dx dt. All right, because 6y will derive to 6 when we need the chain rule, 9x will derive to 9, and again we need the chain rule. Well, we're told that dy dt is 4, so moving down here we have 6 times 4 is equal to 9 dx dt, which is cool because we want to find out what dx dt is. So dx dt we can see is going to be 24 divided by 9. Right? And that can simplify to 8 over 3, which is the fraction, the decimal approximation is 2.667. For number 6, we have the radius of a circle is decreasing at a constant rate. So radius changing at a rate. So our dr dt is given to us. It's 0.1. Now we're told that the radius is decreasing. So when we have a decreasing rate, that means that it will be negative. That's a 1 right there. All right. We want to find the rate of change of the area, so we're looking for dA dt, but we want it in terms of the circumference. So this is similar to one of our homework problems. We're looking for an equation that's going to have dA dt on one side and c on the other, with maybe some other stuff involved. That's what our goal is. So let's get our area formula going. Well, we know what the area of a circle is. It's pi r squared. We're going to derive it. So we have dA dt is equal to 2 pi r dr dt. Well, that's good for us because we're interested in the circumference. And one of the other formulas that we remember from our earlier math classes is that circumference is pi d, or 2 pi r. Well, there's our 2 pi r. So we can sub 2 pi r out, and we can sub c in. But we know that dr dt is negative 1/10 of a centimeter per second. So we have C times negative 1/10. So our answer will be B. And question number 7 was rather challenging. All right, we have a triangle. We're interested about the area of the triangle. We know that the formula for the area of a triangle is 1/2 base times height. And we're given some information about this triangle. The base is changing at a rate of 3 inches per minute. All right, so we know that dB dt is equal to 3. The height is decreasing at a rate of 3 inches per minute. So dH dt will also have a 3, but it's going to be negative because of the decreasing rate. Well, in order to get dB dt and dH dt into our equation, once again we're going to have to derive. So we're going to derive both sides with respect to time. And because we have b times h on the right side, we're going to have to use the product rule. The 1/2 is a coefficient, so it can stay. And now derive the first, which is dB dt, but keep the second, so h is unchanged. Plus, now keep the first, b, derive the second, dH dt. And this can be in any order because of the commutative property. So, dA dt is equal to 1/2. We have no values for h and b, but we do know that dB dt is 3, and dH dt is negative 3. So now that we have this data right here, let's see if we can answer the question. Which of the following must be true about the area of the triangle? The area is always increasing, it's always decreasing, it remains constant, or it's only decreasing when b is less than h or b is greater than h. Right. Well, in order for the area to remain constant, the change would have to be 0. The change is only going to be 0 at the instant when the height is equal to the base. When the height is equal to the base, this will produce a 0, so the change will be 0. But the height's not always equal to the base because both the base and the height are changing. So E is out. A will be increasing if the area is changing is positive. Well, this area will be positive, but only if h is larger than b. If h is larger than b, then 3h will be larger than 3b, and this will be a positive value. But h is not always going to be larger than b, so the area will not always be increasing, nor will it always be decreasing. So when does it change? Well, it changes, we want decreasing, so we want it to be less than 0. So this expression right here, the 1/2 doesn't really matter, this expression right here will be less than 0 when b is greater than h. Say that b is 4 and h is only 3. 3 times 3 is 9, 3 times 4 is 12. 9 minus 4 is 12, is negative 3. Negative 3 times 1/2 is negative 3/2. That's a negative change. That's when it's decreasing, when b is greater than h. So the answer is D.